We are enhancing the secret messages project from the YByte Python curriculum available at www.ybyte.in. In the class, we learned about something called a Caesar Cipher. Now, in this video, we are going to enhance this by doing something called the Vigenere Cipher. Now, this is a French word, so, pardon me if my pronunciation is not absolutely accurate, but let's focus on the idea. Basically, this is a form of a generalized Caesar cipher. Now, remember the way the Caesar cipher worked is that we shifted every letter, which is also known as plain text, by a certain fixed amount. For example, in this illustration, a shift of 3, which means that U became X, V became Y, W became A, W became Z, X became A, and so on and so forth. A itself became D, and so on and so forth. Now, every letter got the same shift, which makes it kind of, not too hard to actually break. But in this Vigenere Cipher, we basically go and generalize this. We do not shift every letter by the same amount. In fact, what we do is that we have something called a key. For example, in this case, key could be say 1, 2, 3, 4. We are going to shift these letters as the key dictates, which means that, for example, if a message is say turn right, I'm going to take my T shifted by 1, so it becomes U. I'm going to take my U shifted by 2, becomes W, take R shift by 3, take N shift by 4. I have a space, so I don't do anything here. I come to R, I shift by 2, it becomes T, and so on and so forth. Basically, what I'm doing is that I'm taking every letter here, shifting it by what the key says, and key is basically going 1, 2, 3, 4, 1, 2, 3, 4, and so on and so forth. So obviously every letter is getting a different shift, and that makes it quite interesting. Number one, notice that the key could be as long as short as you want. If the key were of length 1, if the key had all the letters, let's say all the numbers exactly equal, then we are back to a Caesar shift. However, we can have key, let's say in this case, and we get different shifts. Now, this is quite interesting because notice we are getting two U's over here, but both of these have come from a different letter because again, the shift is determined by this key. Now, very often key is mentioned as letters. So for example, 1, 2, 3, 4 may be written as B, C, D, E. Sometimes you even take English words as the key, but really the idea is same or at least very similar. So I'm going to keep it simple. In our case, key will have numbers from 0 to 25 because that's the amount of shift we are going to give in English, and it can be of any length. Now let's see how we can do this. First, let's see the encoding and then we look at the decoding in a separate video. Encoding this is really not hard. All we have to do is to run multiple Caesar ciphers, but we have to just shift this by what is on the key. So that's what I'm going to do. I'm going to take my code for the Caesar cipher. I'm going to call it, let's say, Vigenere Cipher by the name. All I'm really doing really is that I'm just finding out key I modulo length of key. Now this is very interesting. Remember the way Caesar cipher works is by shifting everything by a fixed amount. So previously I was giving n as a as an input, but now I'm giving key as an input. This I here is the for loop, is part of the for loop. It's a running variable. Key is a list. So what's going on is that when I'm doing I modulo key, all I'm doing is that I'm converting this running index I to an index that goes to say 0, 1, 2, length of key minus 1, again 0, 1, 2, length of key minus 1, which is same as saying that I'm going to shift, let's say, first letter by 1, second letter by 2, third letter by 3, by 4, depending on what's on the key. Once I do this, then I ensure that every successive letter gets a new shift as determined by the list key. And this is all I need. So I'm going to put this in my code. Let's get here to my code. Remember, I have this Caesar cipher code. So I'm just going to again copy this. Let's say I copy this over here, and I say, let me just, instead of Caesar cipher, let's call it Vigenere Cipher. So Vigenere, let's say, and I'll say call this a key. So I'm going to give a message and a key. Remember, previously I was shifting every letter by this n, but here all I'm going to do is that I'm just going to say key, I modulo length of key. Now this makes sense because I is going from 0, 1, 2, 3, 4 all the way to length of x minus 1. By doing modulo length of key, I'm making it go, let's say 0, 1, 2 till the length of key minus 1 and then again 0. So, and when I'm doing key of that index, basically I'm applying different values of the key all the time. Let's see this working. So if I were to, let's say, do, let's say I call it xv is, for example, Vigenere, Vigenere Cipher. Let's just use the same, let's say, same text and the key that we had seen before. So I give a key of 1, 2, 3 and say 4. If I do this, I get x of let's say XV is UWUR TLKIV, and that's, and notice that's exactly what I had when I had done it by hand earlier. Now let's say I were to run my Vigenere Cipher with key which is all 4444, let's say, then I am, basically back to being a Caesar Cipher, and I can verify that by saying, okay, let me just do this again, CAESAR Cipher, and let's say the same turn right and with a shift of 4. I will get exactly the same as expected, because really with the key being all fours, Caesar Cipher is same as the Vigenere Cipher. In fact, on this note, we can also see that if I were to, let's say, run this with just, let's say, two elements, that's also fine, because the key will, in this case is just exactly the same. But let's say I were to run this as 4 and 24. Now clearly my XV will be different, because each one of the letters is getting a shift of 4, then 24, 4, 24, and so on and so forth. We'll come back with another video where we'll see how we can decode this. It's actually quite interesting as well, quite closely related to Caesar Cipher, but I hope you found this interesting. In general, if you think this way of learning gets you thinking, is a lot of fun, then do look at our website, because we have tons of such activities that you can learn programming from. Take care. Thank you so much. Bye bye.